All right, for lesson 8.2, our learning target is going to have three different parts to it. We're going to be able to convert between radians and degrees. We're going to sketch angles in standard position, and we're going to be able to calculate coterminal angles in both radians and degrees. So let's go ahead and get started. The first kind of part of this lesson has just some vocabulary terms. Some of these terms you may have heard before, and some maybe you have never seen before. So let's go through and make sure we kind of know what all of these terms mean. So, an angle, kind of start off slow, an angle is determined by rotating a ray about its vertex. The starting position of the ray we call the initial side, right? Initial meaning the beginning of where we're starting of the angle, and the position after the rotation is called the terminal side. So we start with our initial and we end with the terminal. In standard position, the initial side of an angle coincides with the positive side of our x-axis. So what that means is when we start an angle, we're going to start from right here, and then we're going to rotate from that positive side of the x-axis. Angles that have the same initial and terminal sides are what is called coterminal. That's one of our new words for today. You may not have heard that word today, but it basically means if your angle is either here or we rotate all the way around and then we still end up here, those are called coterminal angles. Some additional vocabulary. There are two different ways to measure angles. The first is in degrees, right? We can kind of remember from probably geometry class. Hopefully you got out those protractors and measured angles using degrees. The other way is called radians. Positive angles are generated by a counterclockwise. So this is, when we're first learning angles, you may want to go in a clockwise rotation, but if we see a positive angle, we're going to actually go counterclockwise this way. Whereas negative angles, we're going to form those by doing a clockwise rotation. So if we get a negative angle, we're going to start here and go this way. And just the more we practice it, the more you'll be familiar with it. So let's go ahead and get started. We're going to sketch an angle. We're going to get to one of our first learning targets. We're going to sketch an angle in the standard position with these measures. Now, as of right now, right, I just have a standard XY axis here, a coordinate plane. But let's go ahead and let's label all of the different angles that are around. So since I start right here from the positive side, this is 0 degrees. Up here, 90 degrees because we're going to be rotating counterclockwise. So the first kind of major angle I hit there is 90. Then we have 180 degrees. Hopefully remember our straight angles, right, are 180 degrees. And then down here we have 270. So we can kind of keep rotating, right? If we came back up here, this would be 360. If we came back up here, this would be 450. So we can keep going around and around and around. But these are kind of the main ones that we have to make sure we understand how the coordinate plane works with a counterclockwise rotation. So if I want to draw 120 degrees, right, 120 degrees is about here. I'm not going to have you get out a protractor. It really is just so that we can kind of estimate where 120 degrees is. And there we go. That's about where the terminal side of the angle, right, our initial side, would be right here on the x-axis. That is where our angle would form 120 degrees. Now let's talk about 560 degrees, right? So again, I have the exact same setup. If I rotate all the way around, I've only gone 360 degrees. So I need to go another 200 degrees. So to go another 200 degrees to get to 560 degrees, I go here to go 180 degrees more and then a little bit more. So my 560 degree angle is right here. And you don't have to draw the spiral. I really just drew that so you could kind of see where it's coming from, right? There's going to be a 20-degree difference between here and the x-axis, just to make sure we understand why the terminal side of the angle would end there. Now our last one, we have a negative 300 degrees. So negative 300 means I'm going to go clockwise instead of counterclockwise. So if I want to kind of redraw or relabel kind of my axis here, I'm going to have 0 degrees, and then down here is going to be negative 90 degrees. Over here is going to be negative 180 degrees, and up here, negative 270 degrees. And that may help you to kind of see that, all right, if I want to get to negative 300, I'm going to rotate all the way till about here, and that's going to be my negative 300 degrees. And the difference, or the distance, between this terminal side and my x-axis is 60 degrees. And you don't necessarily have to label that. Again, I'm just trying to kind of show you how we would find these points. We would find the location of these angles. So there's our first learning target, is being able to sketch these angles in standard position. One of our other learning targets is to find what we call coterminal angles. So coterminal angles are angles that wind up being in the same location. So this angle here, as well as, if I kind of rotate all the way around, and this angle here, notice how they wind up on top of each other. It's just the blue angle I had to circle all the way around. Those actually are coterminal angles. They end up being in the exact same location. So in order to find coterminal angles, all we have to do is add or subtract one full rotation around. So we add or subtract one full rotation around is 360 degrees. So if I add 360 degrees, I get 420 degrees. If I subtract, I get negative 300 degrees. But you'll notice the question asked for 3. So if I have these two, which I now know are coterminal, I can add another 360 degrees to the 420 to get 780 degrees, or I could subtract another 360 degrees from this one and get negative 660 degrees. So I know the example only asked for 3 and I'm giving you 4. It really is just to show you that all of these angles would be considered coterminal angles with 60 degrees. Let's do the exact same thing with our next example. We're going to add or subtract 360 degrees from this negative 215 degrees. So I get 145 degrees when I add 360. If I subtract 360, I get negative 575 degrees. And then I need to find a third, right? I'm asked for a third, so why don't I take this 145 degrees and add another 360 degrees, and I get 505 degrees. So there's our 3 angles there. And you'll see the little hint below, right? Make sure you add to find a positive, subtract to find a negative, although it really depends on what angle you're starting with. But really just the adding and the subtracting of 360 degrees will get you those coterminal angles. So let's talk a little bit about this other way of measuring angles. It's called a radian, okay? So if we kind of think about a circle, okay? Let's just think about a circle, and we have our center here. Usually we label our center O or some kind of letter. And here I have 2 radiuses, right? A radius connects the center of the circle to the outside of the circle. Well, a radian is basically, if I picked up this radius and I laid it down on the circle, it would be the exact same length. So this here represents 1 radian, because it's the value of the radius. So here I have a radius, and then I also have another radius here, and I call that a radian. And so the question is, right, how do I determine how many radiuses or radians go around a circle? Well, let's see. So let's see if we can kind of estimate it. If I do another radius about here, there's another R, another radius about here, it looks like I have a little bit left over. Maybe I could draw a straight line there. So I get 3 and a little bit more radiuses. Anybody have any guess as to how many radiuses fit in a half circle? Well, the answer is kind of that special answer, pi, which we normally approximate to 3.14. So here's kind of, this is where the whole idea is, right? If I'm thinking in terms of radiuses, in terms of r, I can get 3.14 radiuses to cover half of a circle. I'll say that again. I can get about 3.14 radiuses that cover half of a circle. So if I want to talk about a conversion, right, to go 180 degrees or a straight line here, it's going to take me about pi radians. Which, right, this is kind of why we use this when we calculate circumference. This is why we use the pi symbol, because radiuses are directly related to the circumference around a circle. So if we want to go all the way around, right, I want to also include all of the radiuses down here, right? I'm going to have 3 and a little bit more. To go all the way around a circle, it's going to be 2 pi radians. And what I did is I linked a video down here. I'll link it on my Google Classroom so that you can watch it. It's just about 5 minutes, not too long. Just a different person kind of explaining what I just did as well. I know sometimes it's nice to hear it, right, from some multiple sources to make sure we kind of sink in. But ultimately, what we have here is we have some units that we can work with, right? The same way we know 12 inches is equal to 1 foot, and I can use these interchangeably. Now that I know kind of the standard units here, these can also be used interchangeably. So that's what we're going to use. When we start converting and whatnot, we're going to start to use this understanding of how many radians fit in an entire circle. So let's talk about circumference, right? The circumference of a circle. Can we remember our formula for the circumference? So the circumference of a circle is 2 pi r, right? Because we know 2 pi around the circle, and if we know the length of our radius, that's going to tell us the exact length of our circumference all the way around. So if I just have a radius of 1, my circumference is 2 pi. Right? And hopefully we can kind of see that pattern, that connection, that therefore the amount of radians in one circle, like we just showed, is 2 pi, right? This number is going to come up all the time, especially as we start studying the unit circle a bit more. We're going to have to be able to transfer back and forth between radians and degrees. So let's go ahead and we're going to start on the unit circle. Now today, we're not going to finish it in any way, shape, or form. We're just going to kind of get started building what we call our unit circles, which is basically the foundation of all trigonometry. We have to kind of memorize what the unit circle looks like. It's going to help us as we kind of go through the entire unit. So what we're going to do is we're going to take a whole circle, and instead of labeling it with degrees, we're going to also label it with radians. And I always like to kind of think of it as like a pie that we're cutting up. So hopefully as you come along with me for this ride, kind of see where we're going here. So I'm going to label the degrees on the inside here, and I'm going to label the radians on the outside. However you want to label your diagram, completely up to you. So I know, right, here I'm going to have my 0 radians or 0 degrees, right? Same thing. So I'll label my degrees in here. And then as I go around the circle, right, up here, I've got my 90 degrees, 180 degrees, 270 degrees, and then I'm back here, which is also 360 degrees. Well, let's start labeling these as well with the radians. So I start at 0, and let's think about it. Maybe we don't know all of the different radian measures yet, but we do know when I come all the way over here, I get to pi radians. And then when I come all the way down around here, 0 and 2 pi are going to be at the exact same location. So now it's up to us to kind of fill in some of these other parts as we go around. And I recommend that maybe you use colored pencils or markers if you have, it kind of helps to separate everything out. What I'm going to do first is I'm going to take kind of my pi and my 2 pi, and I'm going to break that pi up, meaning the pi is just the semicircle, the top half here. I'm just going to break it up into 6 pieces. So I'm going to hopefully be as straight as possible, and I'm going to kind of use this as one of my pi's as well. Notice these lines are already drawn here to help us. It's not well. There we go. Okay, so I start right from my terminal side here, and now I have 1, 2, 3, 4, 5, 6. I have 6 pieces of pie. Okay, so these 6 pieces of pie, basically I took pi and I've divided it into these 6 quadrants, or I've taken 180 degrees and I've divided it into 6 parts. So if I take 180 degrees and I divide it into 6 pieces, well, each one of these is equal to 30 degrees. So I've got 30 degrees here. 30 plus 30 is 60 degrees. 60 plus 30 gets us to our 90 degrees. 90 plus 30, 120 degrees. And 120 degrees plus 30 gets us to our 150 degrees. So I've written out my degrees for these 6 pieces of pie up here. Now let's talk about the radian measure, right? I'm going to take this pi and split it up by 6 as well. So that tells me each one of these pies is 1 pi over 6. So I've got 1 pi over 6. Up here I have 2 pi over 6. And how does 2 pi over 6 simplify down? Pi over 3. Up here I've got 3 pi over 6. And how does 3 pi over 6 simplify down? Well, it's pi over 2. 4 pi over 6, right? That's going to simplify down to 2 pi over 3. And then I have 5 pi over 6. Last but not least, right, I have 6 pi over 6, which is going to simplify down to that pi. So I like to think of it in terms of it's going to make you use your fractions, right? But it's going to help us to remember 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 pi. Hopefully that helps. You can always convert as well, but I think sometimes it's easier to think of it as a fractional standpoint. Let's go ahead and do the remaining 30-degree increments. So we're going to take the bottom half pi and we're going to split that up as well. And let's make sure we have our degrees in here first, right? So each one of these pies is 30 degrees. So as I kind of go around, this is 210 degrees, 240 degrees, my 270 degrees, 300 degrees, 330 degrees. Now let's keep going, right? Because I was here at 6 pi over 6. So my next one up would be 7 pi over 6. Notice how I just keep counting up by 1/6. I then have 8 pi over 6, which is going to simplify down to 4 pi over 3. We have 9 pi over 6 down here, which that simplifies down to 3 pi over 2. Here I have 10 pi over 6. I have to keep simplifying these fractions. 5 pi over 3. And then last but not least here, 11 pi over 6. When I get back to the center here, right, that would have been 12 pi over 6. And notice the 12 and 6 are going to cancel out to give me that 2. So I get kind of back to where I started, and I could keep going, right? I could go 13 pi over 6, 14 pi over 6, 15 pi over 6. You can keep going around and around. The other main angle that we have here is I'm gonna kind of switch gears, so I recommend switching to a different color pencil if you have it. And instead of breaking kind of my top pi into 6 parts, I'm gonna break it into 4 parts. So 1, 2, 3, and then 4. So now up here, right, I have this whole section here is 1/4 of a pi, and then another 1/4 of a pi, and then another 1/4 of a pi, and lastly down here. So I have 1/4 of a pi, which is pi over 4, 2 pi over 4, which is pi over 2, simplifies down the same, 3 pi over 4, and then 4 pi over 4, which gets us back to pi as well. So let's fill in the degrees, right? If I take 180 degrees and divide it by 4, because remember we're just talking about the top part of the circle here, I get that each one of these is going to be 45 degrees. So I have 45 degrees, 90 degrees, 135 degrees, and then 180 degrees. Let's do the same down along here, right? 1, 2, 3, and then back to our center here at 4. I'm going to keep just adding our 45 degrees. So I get 225 degrees, another 45 gets me to 270, 315 degrees, and then another 45 gets me back to the 360 degrees. Now let's keep counting our pi's, right? I had 4 pi over 4, so the next one is 5 pi over 4. Then I have 6 pi over 4, which simplifies down to our 3 pi over 2, and then 7 pi over 4. Last but not least, I have our 8 pi over 4, which simplifies down to our 2 pi. I want to make sure that we know these mean the same thing, right? Big old slash here. And there we have kind of the beginning construction of our unit circle by introducing both the degree measures of all of these main angles as well as the radian measures of all of these. So let's continue on with our second learning target, which is to say, okay, now that I know the connection between degrees and radians, how do I convert? How do I convert from one, or sorry, not how do I convert, how do I find coterminal angles if instead of them being in degrees, I'm given them in radians? Well, before, right, when we found coterminal angles back here, we added or subtracted 360 degrees. So in order to find coterminal angles, I'm going to add or subtract 2 pi, right? Because 2 pi is the same thing as 360 degrees. So I am going to have to do a little fraction math on these, right? I have to add or subtract 2 pi. So here's how I do it. Pi over 4 plus 2 pi. Notice I am adding fractions. In order to add fractions, I need a common denominator. And right now my 2 pi does not have a common denominator. So I'm going to multiply by 4 over 4. So I wind up with pi over 4 plus 8 pi over 4. I now have a nice common denominator. Remember, there's a 1 in front of this pi. So I wind up getting 9 pi over 4, right? When I add fractions, I add my numerators, keep my denominators. Now let's do the subtraction one. Instead of just kind of adding the 2 pi over 4 or subtracting the 2 pi here, not 2 pi over 4, 8 pi over 4, right? I need to subtract 2 pi. I've got the same problem, right? I need to have a common denominator. So I have pi over 4 minus 8 pi over 4. Remember, there's a 1 out in front of there. When I add or subtract fractions, I keep my denominator and just subtract my numerators. So I get negative 7 pi over 4. Go ahead and try this next one on your own. We're going to add 2 pi. I need to have a common denominator. So I get negative 5 pi over 6 plus, oh, I needed to multiply here by, oh, let me go back a second. Right, I need to have a 6 there. Plus 12 pi over 6, right? Now I have a common denominator. That looks a little bit better. Negative 5 pi plus 12 pi, 7 pi over 6. Now let's find a negative one, negative 5 pi over 6 minus 2 pi. Got to multiply by that 6 over 6. So I get negative 5 pi over 6 minus 12 pi over 6. Subtract my numerators, keep my denominators. So I get a 7 pi over 6 and a negative 17 pi over 6, and those are all coterminal angles with the negative 5 pi over 6 that I started with. So really, it's just kind of practicing your understanding of fractions. Not a bad thing for us to do. At this point, if you would like a little practice on IXL, it's under Algebra 2, and it is the lesson or the skill Y5. And for the most part, IXL is having you do it in degrees, but they do have some radian questions in there as well. Let's move on to our last learning target, which is to convert between the two. And it's really not that bad since we know, right, pi radians is equal to 180 degrees. So you just have to figure out, okay, which one do I multiply by to kind of get to the other form. So if I'm converting from degrees to radians, we're going to multiply by pi over 180. If I'm going to convert the other way from radians to degrees, I multiply by 180 degrees over pi. So let's go ahead and give this a shot with a couple of examples we have. So we've got all of these examples. We'll see, we may not need to do all of them. You may kind of get the hang of it pretty quickly. So I have negative pi over 2 radians. And since I want to convert to degrees, I'm going to multiply by, right, 180 degrees over pi, because basically this is just the number 1, right? 180 degrees and pi are equivalent to each other, so they really are just the number 1. My pi's go ahead and cancel out, so I get negative 180 degrees divided by 2, negative 90 degrees. Let's go ahead and try letter B. I get 7 pi over 3 radians, right? So I'm going to multiply by 180 degrees over pi. My pi's simply cancel out, and then I'm going to pick up my calculator, right? Now I'm going to do some additional math. So I'm going to do 7 times 180 degrees divided by 3. I get out 420 degrees. I encourage you to go ahead and try C and D on your own. C is 135 degrees, and D is negative 288 degrees. Let's go ahead and convert the other way. Now for this one, I definitely recommend that you use a calculator, especially our calculators where they have the math enter feature, which allows you to convert to a fraction, right? It's really nice not having to simplify fractions ourselves when we have a resource provided to us that we can use. It says to find a coterminal angle as well, but what we're going to do is we're really just going to practice the conversion. I know this video is getting a little bit long, and I just want to make sure that we kind of finish out that third learning target, which is the conversion. So for letter A, I have negative 45 degrees. So I need to multiply, in this case, by pi over 180 degrees, right? I'm going to flip-flop my numerator and denominator from last time. Now my degrees, right, that little degree symbol cancels out nicely. So I get negative 45 pi over 180 degrees. So here's what I mean. It's important to pick up the calculator and try it. I'm going to go ahead and use my calculator to simplify this fraction for me. So I put into the calculator negative 45 divided by 180, and then math enter, and I get out negative 1/4, or negative pi over 4. So there we go, we've converted it into radians. Let's go ahead and try the same. In this case, why don't we jump over to letter D? I have negative 300 degrees. I'm going to multiply by pi over 180 degrees, so my degrees cancel out nicely. I get negative 300 pi over 180, and I just need to simplify this fraction down, right? Just need to figure out how this fraction simplifies down. And it winds up simplifying down to negative, let's see what we got here, negative 5 pi over 3, or negative 5/3. Let me just double check. So I wind up with negative, I want to make sure I keep it negative, 5 pi over 3. So here we've gone ahead and converted these into radians, and all we really had to do was multiply by the reciprocal from the previous problems. Now, I would encourage you to try B and C on your own. B is going to be negative 3 pi over 2, so you can kind of check your work there. And C is going to be negative 5 pi over 6, so you can check that work as well. So that concludes our 3 learning targets for 8.2. If you would like some more practice on converting under iExcel, under Algebra 2, it is Y1 skill. So I would encourage you to practice those if you weren't able to come to class. Thank you.